Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. This week, my guest is Nick Dutton. He is a technical and strategic advisor to Last Mile Semiconductor. How you doing, Nick?
I am all right. Thanks a lot for having me here.
My pleasure. So for the audience's sake, we met a couple of weeks ago at the Unify event, which is put on by the Connectivity Standards Alliance. And they talk about everything to do with standards related to connectivity, for lack of a better description. Um, and you and I spoke about NR Plus, DECT NR Plus, which I'm sort of familiar with. I did a little research after the fact, but here we go. I'm going to be the, what's the right word? Do we need another wireless protocol to do these stuff? I mean, we have LoRaWAN, we have Wi-Fi Halo, we have NB-IoT, we have Bluetooth Low Energy. Here we are with another one. Why do we need another one?
You know, that's a
How's
great
that for an
question.
intro? Setting the stage for you on a positive note.
That's a really good question. And to be honest with you, I'd like to answer the question by saying we don't. In all honesty, I mean, that'll get me fired tomorrow, to be fair. But
Well, thank you very much, Nick. It was nice chatting with you.
that's the answer I'd like to give you. The reality of it is that, you know, things have changed so much. When all the previous stuff was created, the load in terms of connectivity was not the same. The global reach was not the same. A lot of the rules that define this country versus that country, this modulation versus that modulation, those rules are not really unified. You mentioned some sub-gigahertz, for example. Some countries are in the 800s, some countries are in the 900s, some countries have little bandwidth, some countries have big bandwidth. What this really does is it's changing the user experience, right? Let's say that is true for sub-gigahertz. If you take the step the other way, you move up into the high frequencies. Let's go for 2.4, super common, right? Here's the problem: there's so much going on in there, but the organization wasn't there for interoperability, and so there's a lot of compromises there too. So the thing that we'd really like to do is go back in time and set it up again, right? Knowing what we know now, let's go back in time. Let's set it all up again. Let's make it so that it doesn't matter where we are. The global feel is the same. The rules are the same. Me as a manufacturer, I can ship from A to B, and everything's the same. You can't do that anymore. There is no coming together. It's gone. It's past. It's sailed. So what NR Plus is, to come back to your ultimate question, it's a step back in time. What NR Plus has done is it's gone back, found this golden frequency that's everywhere in the world.
Which is
1.9 gigahertz.
Okay.
And what they've done is they've said, what's there right now? Well, cordless phones are there right now. Nobody has a cordless phone anymore. So what's happened is you've got these big names, Siemens, Schneider, Legrand, Nordic, Last Mile. You've got these companies that have come together and said, hey, DECT Forum, you're responsible for this. Why don't we pivot? And so now you got this totally clean frequency, which is dedicated to purpose, that is also global. That's one of the reasons for doing what we're all doing here. It's not that we want another protocol. It's that we want one that can be used for what we're doing today without compromise from yesterday. That was a long answer. But
what are the applications that make sense for this protocol? And before we do that, what is the bandwidth that you're talking about here?
Oh, the bandwidth is broad. You can stick video out over this stuff. So that's great. I mean, it's something like I think it's 2.5 meg per channel is allowed. So it's broad. So but let me get to your question that you asked here. You asked You asked what the applications are.
Right.
Well, here's the way I'm going to answer that. I'm going to turn around to you and say, the consumer applications as a whole, they are super well serviced, right? You got Wi-Fi, you got Bluetooth, you got Zigbee, Thread, everything is out there servicing that. Now, the other thing about the consumer space is we're relatively short range. We don't really need to worry beyond our home. But if we do start to think about where IoT is going and in that bigger picture, you're now talking about MDUs. So that's beyond the home. That's the managed environment of the home, which the gym, the front door, 3 steps down. But then again, it can also be the smart cities, the street lights, the smart metering, the smart irrigation. So you're expanding really into the smart buildings, the smart cities, the smart metering. You're opening up a lot of industrial and commercial applications that have historically struggled. Smart metering is a fantastic example. They've done great around the world, but they're forced into 868 in Europe. Very narrow range. But at the same time, you're trying to stick EVs on top, you're trying to stick solar on top, load shedding. It's a perfect market that can be addressed by this broader bandwidth and yet still very penetrating radio.
For a lot of these protocols, like LoRa or Wi-Fi Halo, they're great for what they do, but it seems to be very chicken and egg, and we don't have any devices yet, or a very small number of devices. And I assume that's the same thing with NR Plus. It's until we get more devices, people won't design to it. And until people design to it, we won't have more devices. So what do you do to get past that and get some momentum for it?
Well, I think that's very much a consumer problem. I think the problem in the consumer space is until you have that moving, it gets hard to get the adoption. In the industrial and commercial space, those volumes are a lot higher. The customers are a lot focused. The applications are a lot more focused. So in those areas, the adoption doesn't have to be pictured the way you positioned it, right? If that makes sense.
It does, but it's not there yet today, is it? Or am I?
No, it's not there today. This is a relatively young protocol. I think it's only touching on 3 years, right? When you look at consumer protocols, they typically take 10 years, right? You name them, they all took that long. In the industrial and commercial space, it's a lot smaller. And historically, that's been more centered around the fact that space has been very proprietary. You have one person, they're making it for themselves. But where we've changed in life is the internet is a key part of everything. The billing models, and business models associated around that. So you're wanting things with IPv6, right? Which NR Plus has. You're wanting things with good bandwidth to be able to do standardized, and that's a key thing, standardized over-the-air updates. If you've got 5 million smart meters, when do you need to do those updates? You can't do them manually, but you need the system to be able to have the bandwidth to do them swiftly.
What's the range you're talking about? Because I know in my neighborhood, they drive around in a truck to do all this stuff. So I guess they're 100 meters away from my meter when they're reading and potentially updating. What does NR Plus have to be?
Well, there's the technical answer and there's the actual answer. So the technical answer is that the specification allows over 20 dBm. So that's kilometers of range, right? But by default, the NR Plus protocol is mesh, right? So the reality of it is the range only needs to be as far as the next node, right? So in my neighborhood, that's not very far at all. In more rural neighborhoods, that may be more so. But the protocol also, just like Wi-Fi, has this power adaptivity thing. So it will step up the power
Mhm.
as necessary and step down the power as necessary. NR Plus is designed for battery operated products, right? So with that in mind, you do not want it to be trying to get the maximum of range, even though it can, right?
Oh, I didn't realize that you were looking at battery powered devices.
Oh,
That's
certainly. Yeah. Again, the market might define things a little bit differently. If you're
Mhm.
talking about street lights, obviously we don't need battery
Mhm.
power. If we're talking about smart metering, obviously we don't need battery power. But if we're starting to talk about I don't know, leak sensors or pressure sensors on
Mhm.
gas lines or on water lines, just to stay in the smart city space, even irrigation, those kind of things may be battery powered and maybe needed for that play. Does that make sense?
Sure, it does.
Also, actually, I can expand a little bit further on that when we talk about smart buildings. So, one of the things that people don't really recognize is when you take into account the cost of labor and all that kind of stuff with regards to pulling cable. Power cable is about $6 a foot. Data cable is about $2 a foot. Right
Mhm.
now, let's look at that MDU space or that hotel space. We want to be able to use batteries in those scenarios, the door locks on hotel rooms,
Mhm.
the batteries in the maid call, or I don't really know what you call it, but the emergency panic buttons that maids might
Mhm.
walk around with. All of those are batteries, but they need to be able to feed into this bigger managed building network, if that makes sense.
Yeah, I didn't know the maids walked around with panic buttons.
They do nowadays. Yeah, it's supposed to be a big problem. And in fact, sometimes if you're as nerdy as me, you might actually spot these little boxes in a lot of the hotel rooms, which can be things like occupancy sensors to see if the maid even needs to bother there. But then they have these panic buttons nowadays, which are used for people who are attacking the maids, which allegedly is a bigger problem than we all give it credit for.
Well, thank gosh for NR Plus then, huh? Saved anyway. Um, uh, okay, so the one question I always ask is it more or less secure than the other protocols, which seem to be pretty secure?
Yeah, well, again, it's coming from the right end of the spectrum. Spectrum's a bad word to choose here, but it's coming from the right point in time. So, as I say, the protocol is relatively young, even though the RF spectrum is good for it in that it's dedicated, but it's coming from the right spot. It was coming from the era where people's concerns around red, CRA, secure elements, and all those kind of things are the starting place for what
Mhm.
this technology is doing. So I would argue, yes, absolutely. The fact that it's a standard is also a big part of that, because when you're creating a standard as opposed to a proprietary solution, you get this input from all the partners that are in that space to make sure that their requirements are captured and their learnings are captured along the way.
Okay, so um, I should have asked this at the very beginning, but what is the history of the protocol?
Yeah, okay. So fundamentally, the history in starts with the frequency, which was owned by DECT. A
Hmm.
couple of the partners in this alliance, if you wish to call it that, kind of came together and said, "Look, we need something that is mesh network, isn't governed by the access point." I should explain that to you for a second. Because this protocol is designed for scale, the likelihood of as the edge node being a great distance away from the access point, you can't put the access point in charge. The
Hmm.
edge nodes have to be in charge of determining what frequencies they want to talk to their neighbors, how much power they need, how many hops they're willing to take into account, versus how much power they're going to use in all those jumps. So example of that is let's see, if you've got a device that just wants to create a heartbeat into the system, you could probably tolerate 100 milliseconds, so it can go the long way, leverage all the 0 dBm power hops. Whereas if I've got that made panic situation, I might want to get the message from A to B as quickly as possible. I see that there's a route that I can take that is only 2 hops. I
Mhm.
might be sticking 20 dBm out, but that's not the priority in this situation, right?
Right. Very good. And what's the future?
What's the future? Oh, how do I interpret what you're asking me there? I
What's
think,
the future of NR plus? If we're having this conversation a year from now, what are we talking about?
well, the future is scale. It's the protocol. It really is not intended for consumer. That doesn't mean the consumer won't be part of it. You know, as I say, if
Mhm.
you're in these MDUs, you still want the message to kind of get through from their home environment to the building environment. So the future is one of scale. So where will you see it? You will see it in smart cities, whether that be bus lane violation stuff, parking meters, street
Mhm.
lights, whatever. You will see it in smart metering because it fixes many of the global problems that you have from region to region. Um, so I think that's really my answer, if that's was answering your question.
Absolutely.
Yeah.
This is exciting stuff. I'm still not totally convinced that we need yet another protocol. Maybe this one replaces one of the existing ones because there are too many. Somebody's got, I won't say somebody's got to win and somebody's got to lose, but somebody's got to be the more prominent and somebody's going to end up being the less prominent. So we'll see what happens as we go forward. Everybody seems
Well,
to have their
let
pluses
me
and
give you
minuses.
those points. It's a global frequency that there's nothing else allowed on. So RF noise is quiet. It's license free, so it wins over cellular. You can be in charge of your own ecosystem, which means you're not waiting on a cellular truck to roll to fix
Hmm.
if something needs fixing. It's the same user experience, no matter whether you're in the Americas or Europe. You're not making sacrifice at the usability level. So it really is that, again, this really comes down to the frequency. It really is that golden frequency that's now been leveraged. That doesn't mean there's anything wrong with the others,
Hmm.
except the others are having to make compromises that NR Plus doesn't.
Okay. Sounds really good, but I guess we just got to wait and see, huh?
Of course. Of course.
Okay. Well, I'll see you in a year and we'll see if you were right and we'll see what happens.
Very good. Thanks again, Rich.
Thank you, Nick. That was Nick Dutton. He's a technical and strategic advisor to Last Mile Semiconductor, and I'm Rich Nass with Embedded Computing Design.